Good morning, everyone. So moving forwards in our coordinate geometry chapter, now let's discuss a bit about distance. So let's say that some person here is at this point A, and let's just assume that this is our origin. So if each of those squares represent one unit, this would be 2 to the right and 1 up. So the coordinates of point A would be 2, 1. Our frame of reference would be like this. So this is our point A here. Now let's say there's another point B at this position here, and we want to find out the distance between those 2 points. So what would be the coordinates of point B? So here it would be 7 and y would be 5. So coordinates of point B are 7 and 5. So if we wanted to find the distance between those 2 points, if we take a close look, we may close a triangle here, and that's a special triangle. That's a right triangle. So since it's a right triangle, let's call this point here, let this be C. And if we apply Pythagoras, we will have that BC squared, which is one of the sides, plus AC squared, which is the other side, is equal to the hypotenuse squared. And the hypotenuse in this case is the distance that we want to find, the distance d. So to find distance d, we will have to do the square root of those 2 segments. Quite simple. Now, what if we apply those values? So for that particular example, what would be the distance? Now, this length here, if you take a look at it, this height of B is 5 and the height of C is 1, so this difference is 4. Also here down below, since the x-coordinate of point C is 7 and the x-coordinate of point A is 2, this distance will be 5. So this is in fact root of 4 squared plus 5 squared. That's root of 16 plus 25, and that's going to be an ugly square root of 41. And that is approximately 6.40 if we keep this up to 3 significant figures. So let's try to write this equation in a more general way. So let point A be given by coordinates xa and ya. Now let point B be given by coordinates xb and yb. So if those are our points, we could assume again that there's this point C here, and we've got this triangle. So when we do BC, we're just calculating the difference between those heights. So BC here, well, let's do CB because it's pointing upwards, but the length will be the same. So if we're talking about length, BC and CB, they are the same length. So if we're talking about vectors, then the direction would matter. So let's just talk about going from C to B. So that's this y, that's y of B minus y of C. In the previous example, we just did the difference of the heights. That's the difference of the heights. What about AC? So if we do AC, we will get x of C minus x of A. And those are actually what we need for the distance, because the distance here is the hypotenuse. So it would be squared. We can get the square to the other side. and it would be the sum of those two squared. So yb minus yc squared plus xc minus xa squared. However, we've got this point c here that we don't really care about because we created this. So we would rather just write everything in terms of a and b. And if you notice here, the height of c is the same as the height of a. They are the same height. And x of c, so the distance of c from the origin here, the horizontal distance will be the same as horizontal distance of b. So those relations may help us deriving one equation which does not depend on point C, which is completely arbitrary. So if we keep doing that, we should find D, and now YC is YA. So that's YB minus YA squared plus XC minus XA. XC is the same thing as XB and XA squared. And this is the simplest version of that formula. And if you notice, it's very, very, very simple. The distance between 2 points is the square root of the distance between the heights squared plus the distance between the difference of the horizontals squared as well. So let's take a look at one more example. So let's assume those 2 points, A and B, and I want to find the distance between them. So now that we know the formula, let's just apply it. So it's the square root of the difference between the x's squared, so that's 6 squared, plus the difference between the y's squared. As simple as that. So 6 squared, 36, and 2 squared is 4. So that's root of 40. And if we factorize 40 by 2 by 2, that would be 2 roots of 10. And root of 10 here is 2 times 10 is 2 times 5, so we cannot factorize any further. If we're asked for the exact value, that's our answer. If we are asked for just a value, we should try and find how much is root of 10, and we would use the calculator for that. And that would be around 6.32. I haven't specified units here, so it's just 6.32 units. And this is up to 3 significant figures. Now, something that you might notice here is that your origin is completely arbitrary, so you can choose any. In this particular problem, I've chosen my origin to be here, but if I chose, for example, my origin and another one to be here, it wouldn't be a problem. The distance is still the same because it shouldn't be, the frame of reference shouldn't matter. So for example, if I take into consideration this new origin, what would be the new coordinates of my points? So let's call out this point A line, so A prime and B prime. A prime here now is 3 units to the left, and y is still 0. B here is 3 units to the right, and y is take away 2. If we calculate our distance, change in x, it's still 6, plus change in y, it's still 2. So this will give us the same result as before. So the frame of reference should not matter. If it matters, then there's something wrong in your solution. Now, there's another case if we're working in 3 dimensions. Our calculation for distance is going to be very, very similar, but now not only we have change of x plus change of y, and now we'll also have change of z, and that's the distance between 2 points in 3D. If you are in 2D, you can just assume that delta z is 0, and then what happens is that this equation will be exactly the same as for 2 dimensions. But let's assume that that's not the case. Let's say that it's 3D now. And I'm giving you a point 1, negative 1 and 2, and another point 3, 5, and negative 3. And if you're asked for the distance between those 2 points, you should be able to do it, right? Distance will be the square root. And now what is the difference between x of a and x of b? That's 2. Change of x here is 2. Change of y here is 6. And change of z here is 5. Notice that those negative signs, you will add them, right? The distance is larger. It's a really common mistake for students to do. 2 minus 3, that's negative 1 squared is 1. That's wrong. So 2 squared plus 6 squared plus 5 squared. What I've done here is each of those squared, each of those squared. And, well, 2 squared is 4, 6 squared 36, and 5 squared 25. So this would be root of 65, which is approximately 8.06, 3 significant figures.